All right. So now I'm going to do the limit of this and the limit of that. I'm going to change this to a minus sign so I can switch these around. And this h I'm going to put under each of these, which is mathematically sound. So limit as h approaches 0 of g of x times f of x plus h minus f of x. And then I'm going to put that over h. And then I'm going to change this to a minus sign, which will cause this to take on opposite signs. G of x plus h minus g of x. And I'm also going to put that h under this expression, but I still have this left. Alright, so the algebra comes along and helps us every step of the way. And I'm going to put, I said I would split it up into 2 limits, and actually 3, because we also know the limit of a quotient is the quotient of the limits. So now I've got 3 individual limits in this problem. Let's take the limit here, this first limit. Right here, the limit as h approaches 0 of f of x plus h minus f of x over h should ring a bell, and this doesn't have any h, so the limit as h approaches 0 is not affected by this. So we will get g of x unaltered, and this is the derivative of f of x. So this whole thing in the circle became g of x f prime of x minus something similar over here. The f of x has no h in it, so it can cross the limit sign without being affected by it. And the limit of this is, as x approaches 0, is the derivative of g of x. So what's happening on the bottom? Well, the limit as h approaches 0, we can put a 0 in here for h, and we get we get g of x times g of x. So we get g of x quantity squared. So we can go up and grab what we were starting with, the derivative of a quotient. So when you have two things divided with respect to x, derivative of f of x over g of x with respect to x equals the bottom function. I'll call this the bottom function and the top function. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom function squared. Sorry guys, but that's the way it is. See if I have room to put in an example. Let's do f of x equals 5x minus 2 divided by x squared plus 1. Alright, following this pattern here. So I want the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So to clean that up, I would leave the bottom squared the way it is, but I would multiply out the top and combine like terms. So this becomes 5x squared plus 5, and this is minus 10x squared, and that becomes a positive 4x. I guess that's about it. Alright, so if I put that together, I get a 5x squared, and a minus 10x squared is a minus 5x squared, and the 4x and the 5. And I'll just leave the bottom unaltered. So cleaned up the top and left the bottom like that. So that's how you use this rule. Again, the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. I think I've heard it like this. If you call the first expression u, if you call g of x u, I'm sorry, I guess you call it, how is it? You call this u and you call this v. So if you call the top expression u and the bottom expression v, I've heard it saying u dv minus v du all over, no, that's not it, v du, oh, sorry, u dv minus v du, it's supposed to rhyme, all over the square of what's below. Oh well, I have to remember that little jingle for class tomorrow. It escapes me now. Alright, we'll just do it the old-fashioned way for now. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Alright, little sloppy, but you can do it. Alright, till tomorrow. Bye.